Come on. So this is the first question, and this question actually I have prepared from Peter Sykes. This question I have prepared from Peter Sykes' theory part. Right. Now, so the question is basically an interesting sequence is obtained by the reaction of dilute aqueous ethanolic sodium hydroxide with the series of alkyl halides. Right. These four are the alkyl halides, the series of alkyl halides. And we have mentioned one graph here. And what is the graph? Basically, measurement of their rates of hydrolysis with the dilute aqueous ethanolic NaOH. This is the graph. And graph is right now representing the PQRS4 compound. Right now, we don't know which one is P, which one is Q, which one is R, and which one is S. So these PQRS are these four compounds, 1, 2, 3, 4, right? And the graph is representing SN1 and SN2. Please, Ria, mute your mic. And graph is representing SN2 and SN1 rate. This graph is given in Peter Sykes in a theory part. From that graph, actually, I have prepared this question in my book. And now you have to select the correct statement out of these four ABCD. Because from Peter Sykes already, JEE Advanced have prepared one question of ester hydrolysis, right? From the theory part only they have prepared. So like that, I have framed this question. Now you need to decide this. Out of the four options, which one is correct? Maybe one or more than one, right? Come on, check this question, everyone. Only question size is only like looking like big, but that question is not tough. If you think properly on the basic concepts, you can easily get this answer. Okay, so answer is A, C, D only. Any cross question? Answer is A, C, D. If you have cross question, then I'll discuss. Otherwise, I'll discuss the answer ACD, why the answer ACD is coming out. Okay, let me explain first. In this graph now, this is the rate, right? In this rate, actually, what is happening? P compound is having highest rate of SN2. Q compound, actually, this line is showing SN1. Its SN1 rate is lower. SN2 rate is faster. R compound, SN2 rate is lower, SN1 rate is faster. S compound, SN2 rate is lower, SN1 rate is faster. The graph presenting the simple thing only. If you see these four compounds, CS3Br is best for SN2 because in SN2 back attack is required, and this compound is good for SN1 because SN1 is stable cation we are getting. So this is absolutely fine. This S compound should be the fourth compound and the P compound should be the first compound. Among these two, Q and R, obviously Q SN2 rate is high, and for R, SN1 rate is high. If I compare these two compounds, SN2 is good for this and SN1 is good for this. So this compound, this R compound should be third one and the Q compound should be the second one. You got my point? As per this discussion, for hydrolysis of Me2CHBr, rate of SN1 is faster. Yes, absolutely correct. For Me2CHBr, SN2 faster? No. CS3Br and Me3CBr are undergoing ready hydrolysis. Absolutely correct statement. As per the graph, for P compound, rate of hydrolysis is faster, and for this S compound, rate of hydrolysis is faster as compared to the remaining two Q and R. Whereas the two intermediate members being more resistant comparatively. This is the comparison. So this is extremely high SN2, that is extremely high SN1. Remaining two are the intermediates. So as compared to these two, these are more resistant. That is why C statement is also correct. And PQRS are these compounds. Yes, absolutely correct. So answer is ACD. Okay, right? Now see this question. This is just easy question because JEE Advanced already asked such type of question. Advanced paper only. You check this question. Which name of the given alcohol is or are ambiguous? First, you please see the question properly. Such type of question may also come. because that kind of question already came in JEE Advanced for the different actually compound. So which name of given alcohols is are ambiguous? Okay, so don't worry. Secondary butyl alcohol. What is secondary butyl alcohol? Butyl at secondary carbon, OH is there, that is secondary butyl alcohol. As per the first name, right? Isobutyl alcohol is this one. Isobutyl alcohol is this one. Secondary pentyl alcohol, right? And neopentyl alcohol. Neopentyl alcohol is this one. So secondary butyl, the only possibility of secondary butyl is this one only. Because in butyl, either you place OH here or here, both are the same compound only. But in pentyl, there are two positions which can be secondary. That can be secondary pentyl and that can also be secondary pentyl. So secondary pentyl, this is also secondary pentyl, this is also secondary pentyl. But if you check the IUPAC name, this is pentane 2-ol, this is pentane 3-ol. So secondary pentyl alcohol is an ambiguous name because one compound cannot have a two, there's a two compound, they cannot have the same common name. So secondary pentyl alcohol is an ambiguous name. That is not correct because all the common names should be fit for the single compound. So secondary pentyl alcohol is the wrong one because two compounds cannot have the same common name. Right. Good, yeah. Okay. Now you check this next question. This one. This question you check. You read this question first and try to check this answer like. Everyone, because IUPAC name, they are generally, they ask in JEE Advanced paper, some different kind of IUPAC, like not tougher one. They always use the basic concepts. And you must know the spiral meaning. A spiral meaning is just, this is the attachment. Like this is the like alkyl part, which need to attach with this question mark position. That is a CH3, CH2. From this point, this need to attach with the question mark position. That is the question. You must know like what is the question language and what the question is representing. And what they are asking actually, construct the compound 3-ethyl 2,4,5-trimethyl heptane. Anyone? Any doubt?
Yes,
Okay, let me check first. Suppose this is a 2 position, this is 1 position. At 2, suppose if I place this compound and 1 I place this compound, and in the other scenario I place this compound and here I place this compound. Now you simply check the IUPAC naming. IUPAC name, only 3 rules are important. One is a parent chain. First rule is a parent chain. Second rule is a numbering. Third rule is a naming. That is the simple 3 rules are there only in the IUPAC. Longest chain, if you want to check, then what is the longest chain? 1, 2, 3, 4, 5, 6, 7, or 5, 6, 7. But this we need to take because here we are getting more number of side chains, right? I need to start numbering from this point because 2 number I am getting 1 side chain. 3, 4, 5, 6, 7. What should be the name? 3-ethyl 2,4,5-trimethyl heptane. Yes, as he solve again. So the M compound should be on the second position. Yes, absolutely correct. The answer is 2 only. M will come on the second position. So the question is not tough. You try to get the point that kind of language, some different format they actually use in JEE Advanced paper. They always use a basic concept. Now, don't trap in the things. Next question you check. This question I have prepared from Peter Sykes again. This question I have, because acidic strength question they have asked many times. And read the options very carefully because they always give some trap in the options only. When the question is easy, option like structures, they always play with the options. So in JEE Advanced organic part, they never ask unnecessary out of the box question. They will never ask. They play game with the options most of the times. So again, I'm telling you, the answer is A, C, D only. Answer is ACD. This is the absolute answer. Very good here. Very good. Yeah, this question again from Sykes only. See the question properly and read the statement properly. What they're asking, they're saying plus M effect of Cl. They are saying ki plus M effect of Cl in case first may cause the first to be weaker than second. Yes, because in this case plus M effect cannot work from meta position. That is only minus I. And if they are saying ki if plus M is considered, so obviously acidic strength will reduce, because in acidic strength what should happen? If minus charge we are getting, it must disperse over the ring. But if plus M is operating, instead of spreading the charge, they will concentrate the charge. So obviously if plus M effect of Cl we consider in compound first, it will become weaker than second. So first statement is correct. Minus I effect of Cl in case first, if now they are considered it's a minus I effect in first, may however cause the first to be stronger than second. No, in inductive we always check distance, and distance of Cl is more closer. So minus I effect better disperse the charge from meta position instead of the para position, right? So first will not be like stronger, right? The second will be more stronger. So this statement is wrong. Intramolecular H bonding operate in undissociated acid third, but not in fourth. Yes, this is the absolute point. Now I'll tell you this point. Suppose in this compound, the salicylic acid, if I write, suppose this is salicylic acid OH and COOH, I can write this compound in two ways. I can write this compound in two ways. OH and COH double bond O, and instead of here I can write this hydrogen at this site, right? I am writing in two way. Actually the oxygen is showing plus M effect. If you know the resonance thing, double single lone pair, so plus M effect. So O will get positive charge, and when O pull the electron of hydrogen, H will also get positive charge. In this case, O will do resonance like this. O will get minus charge, so this H bonding is feasible. If you check this H bonding, O lone pair resonance are moving like this. O is getting positive, H is also getting positive. This O is also moving, this is also positive. So this O and this H, they cannot get a hydrogen bond. So you must know that in this salicylic acid, phenolic H is showing H bonding with the carbonyl O. This carboxylic acid H is not showing H bonding with the phenolic O. So you must remember that this H is never participate in hydrogen bonding. Only phenolic H is participated in the hydrogen bond. It means that this H is not part. Now you see this case. I already told this is showing a plus M effect. And if this is showing plus positive partial charge, this H is also partial positive charge. So there is no H bonding possible in this case. So the statement is intramolecular H bonding operate in third, but not in fourth is the correct statement. Getting my point? Now, compound first become most acidic among when it Cl at ortho instead of para position. Absolutely correct. If you know the ortho effect in benzoic acid, in that case, everyone know the proper ortho effect of benzoic acid, or should I explain here? Now, so should I explain the ortho effect in benzoic acid, or everyone is comfortable? Okay. Okay, right. I'll explain one small thing in this like benzoic acid part. Bacho, now you see, देखो, in this case, suppose here we have benzoic acid. Benzoic acid is like this. How benzoic acid actually behave? This O lone pair when do resonance, we are getting the structure like this. We are getting structure like this, O minus, double bond OH positive, and this positive charge is responsible to get the positive, to get the negative charge, and it will become benzoate ion, like CO minus double bond O, and now H plus release. This is the way how benzoic acid actually release its H positive. At the same time, benzene ring may also participate. When benzene ring will participate, then this conjugation will hinder. In that case, when this benzene ring participate, this double bond conjugation is hindered. So the H positive release may get some delay in releasing the H plus, because if it is participating, then this double bond O won't take resonance from the oxygen lone pair. When it is not participating, then O positive charge will come bit late. As positive charge come bit late, the H positive release may get some delay. So what we need to do, if I stop this benzene resonance, so delay will disappear. So we do simply what? We place some bulky group on ortho positions. These bulky group, because of the bulky group, steric crowding actually create. It rotate the bond. As bond rotate, now the p orbitals will not be in the plane. And in that case, benzene won't participate, because the system is like these part p orbitals, p orbitals, p orbitals like this. If benzene is suppose turn around, the p orbitals will not be in the parallel position. Resonance will stop. Then simply only this oxygen will do resonance and H plus will come out easily. That is why in benzoic acid, ortho substituent groups, if present, that will become more stronger acid as compared to the normal benzoic acid. That is why in benzoic acid, the size play a major role, because the anion stability we need not to be much bothered, because minus charge is an equivalent resonance. So don't, like, you should not bother about the minus charge dispersion. The main thing is we need to take care about this delay. So to remove this delay, the benzene ring should turn around. So size is the major factor. After size, we check if any group can show like a hydrogen bond, so more charge dispersion may happen. In that case, we check intramolecular hydrogen bonding. And at the last, we check the plus minus M or plus minus I effect. So this is the order. First, you should check size, then you should check intra-H bond, third, you should check any effect if it is happening here. Right now, in this case, if you check, if I write the order, then the first should be like COOH nitro, the major group, then Br, then Cl, then OH, hydrogen bonding, then OMe, nothing is there. So that is the order which is given in psychs also. If nitro is ortho position, then nitro will be more powerful acid as compared to Br. Br size is bigger than Cl. Cl, in that Cl, size is greater than this OH, and then OH is better than OMe because it can show hydrogen bonding also. So now if you see the question, if I place a Cl here, so that will be better than this. It is absolutely sure, because ortho substituted benzoic acid is more stronger. This is not ortho. And if you check between Cl and OH and OMe, you check the order. First was nitro, then Br, then Cl, then OH, then OMe. So the question is perfectly correct. If compound first Cl is on the ortho position, it will be stronger among the all. You got my point? This question is given in psychs. That kind of question they may ask. You know the question is simple, but they may create a trap in the options.
Sir?
Yes.
Sir, अगर हम लोग एसिडिटी कंपेयर करें ऑप्शन 3 और ऑप्शन 4 में, तो
ऑप्शन 3 और 4 में, तो थर्ड इज बेटर देन 4.
Yes sir, fourth one is better ना?
No, third one is better than 4.
सर बट ऑर्थो इफेक्ट दोनों में कॉमन हो गया, और उसके बाद में हाइड्रोजन
listen beta, listen. Suppose here we have a COOH. Oxygen is having 2 lone pair, then 1 H. Oxygen is having 2 lone pair, then Me. So in any situation, it will be like this only. Why it will create steric crowding when it is having option of lone pair? So steric crowding is not playing any role. Now it may get turned around to get the hydrogen bonding. Listen clearly. And because no molecule want repulsion, molecule want attraction. So here they will turn around in such a manner that methyl should not come closer to COOH. So no steric crowding is working. Here it will turn around to get hydrogen bonding. And what the H bonding will do? Now you see this case here. If this O partial positive, H is also getting partial positive, this O do resonance minus charge. Now this H bonding is actually favoring the H plus release. More the H bonding happen, more the resonance will participate. You got my point? Right, right. Now come on, next question. This question you see, please properly. That kind of question already they have asked in JEE Advanced. I have created one more question. Now you check this. The question in JEE Advanced, they always looks like simple. But if you check properly, reading should be the important tool. You remember everyone. Your reading must be absolutely fine. If you do mistake in reading, your solution will be absolutely incorrect. Okay, now I'll discuss. First, everyone should know that cis, syn, meso, right? What you call like erythro, and trans, syn, racemic. This concept, I think everyone know in hydrocarbon case. On behalf of that, actually, you have solved this question. But you didn't focus that one side we will get a D, other side we will get OH. Meso will never create in the case. You have simply applied the trick only. So A, B, C, D can never be the answer. That only I am telling you. Reading should be like more refined. It should be more absolute, because they will create the trap just by representing, oh, the question is very simple. You simply apply the trick, you will get the answer. And the answer will be like that also. Oh, the question was very easy, sir. I have just simply solved question in 5-10 seconds only. But if you check the question properly, you can't get any meso compound. Come on. BD3A. It is not like bromination case. Hydrogenate, deuteration, bromination. There you can get meso compound. There is no possibility of meso compound. So A can never be the answer. You will feel that, okay, cis, syn, meso. So both will be meso. O and P are identical. That is wrong. Because one side D, one side OH we are getting. There are no two OH, no two deuterium. You can't get meso. M and N are enantiomers. Yes, whether you take a trans, syn, racemic, trans always with the syn addition give racemic. That is okay, correct. This will also give racemic. Are you getting my point? This will also give racemic. First reaction yield racemic mixture. Yes. Second give meso. No. Total 3 fractions obtained. Total 3 fractions. Only 2 fractions you will get. Enantiomeric pair, 1 fraction. Enantiomeric pair, 1 fraction. Because one enantiomeric pair come out on the same boiling point. So only 2 fraction you will get. That is also wrong. Only B option is correct. Not getting the question.
Yes, sir.
That type of mistake you guys can do in original JEE Advanced. That kind of question already came in JEE Advanced. It creates some different one. And this is called illusion basically. Okay, come on, this question. Don't feel that the question is very simple. Please do question very properly. Don't feel that a very small question, this and that. No. Do properly. JEE always creates such kind of questions. Should I check it first? I don't remember answer actually. C4H8O2. Possible esters we need to create. So ester is basically this bivalent group. If I create H here, out of 4 carbon, 1 carbon I have used. So 3 carbon I need to place here. Those 3 carbon can be, first, it can be propyl. Second, it can be isopropyl. Second, that can be isopropyl. Okay, right. Now 1 carbon shift to left side. Now become CS3. And remaining we are getting only 2 carbon, right? This. So only 3 esters, no. 1 more carbon if I shift now ethyl here. and methyl there. Now don't shift this carbon because it will become acid now. So 4 esters we are getting. Now CH3 MgBr axis we are actually attacking. This one O, and here we are having simple propyl. If you attack CH3 MgBr in axis here, first attack O minus, come down, this propyl alcohol will come out, that will become HCOOCH3. If one more attack, if I'll do that, then 2-methyl will come here, and outside we are getting propyl alcohol. In the second case, where we are getting isopropyl, now you check where we are getting isopropyl. If I do the same thing, first I'll get this OH and 2-methyl here, and here I'll get isopropyl alcohol. If one side methyl, other side we have ethyl, I'll do the same thing. I'll get MECOH and 2 times Grignard methyl attack along with the ethanol. And the last one is ethyl, and here we have methyl excess attack, ethyl, and 2 times Grignard attack, that become OH, and outside we are getting methanol. Now you check isopropyl alcohol we are getting, yes. 2 times ethyl we can never get because we are having excess of methyl magnesium bromide, not ethyl magnesium bromide. Here ethyl CH2OH, it means propyl alcohol. Yes, we are getting ethyl and 2 times methyl, the last option. Yes, the answer is ACD, absolutely correct. Yes. Your answer is perfectly correct. Answer is ACD. You guys may miss the option C. I'm telling you what you will miss in examination. You may miss the C option. You got this question, Bacho?
Yes, sir.
Okay. Now you see, this question is in NCERT. Yes, this is NCERT, but don't take the question so easy. The question is given in NCERT. And you must know the reason actually. Because question is okay, but you must know the reason why you are giving this answer. Okay. This is NCERT, right? I think you have read this question somewhere in Hello Alkanes, 12th NCERT. Okay, so you got this question, but the answer is wrong.
B and C.
Dekho, this is NCERT, but your answer is wrong. B and C. Come on. Who gave answer B and C?
Sir, me, Ayush will go.
Ayush, okay. That is also wrong.
Sir, D.
D only. That is again wrong. You see, this is NCERT question. That only I want to tell you. JEE always pick the question which creates some illusion.
So only A.
That is absolutely correct. Answer is A. Now, you only tell me why answer A. This is this SN1, okay. Best cation, that is okay. Secondary cation, okay. Primary cation. But in this cation, you will get only one hyperconjugation. Here you are getting 2 hyperconjugation. Then why this order is correct?
So जैसे उधर cation बनता है और
अच्छा, अरे
rearrangement
तू तो जयपुर वाला है. Actually, why this order is correct? In SN1 we always check the cation stability. Tertiary, then secondary. Primary cases, we don't proceed SN1 reaction. In such primary case where there is no stability of cation, there is no SN1. Hey, this is like this case. In neopentyl case, if you want to do SN1, how you will proceed SN1? No SN1 will proceed. Then how it will proceed? It will proceed if you increase the room temperature more than 25 degrees. Then removal of Br and migration of methyl take place simultaneously. In that case, stable cation directly generate. If you only remove Br, cation is not getting stability. So we increase the temperature. Removal of leaving group, migration of methyl take place simultaneously. Then we get a stable cation. Then only proceed SN1. That same behavior you have to proceed here. No cation is forming here because there is no stability. So removal of Br and migration of H take place simultaneously, then you will get a better cation than this. Because in this case, if you migrate H and remove Br, you will get a secondary cation. Here you will get a tertiary cation. That is why this order is correct. And remaining orders are wrong. This is so anyway wrong. That is primary is okay. Here this is secondary. Here this is primary. Primary should do better SN2 as compared to secondary. Yeah? This is the anyway wrong. So answer is only A. Anyone is getting doubt in this question? I have explained each and every point. Okay. Come to the next point. This question is again good question because that type of question JEE is asking in advanced paper. And these questions only format wise, they seems like a bit tough. But if you try to solve them, you'll get the question is easy on.
Sir, option C.
Yes. That's so easy, yaar. Carbon percentage is given. You simply remove one time, you remove iodine, one time you remove Cl, then only you can get this answer. Answer is C only. Is that okay? Iodine will remove, Cl will be there, then only you will get carbon percentage 57.4. If you remove both of them, then carbon percentage will increase. So you must know these all kind of questions because these all are the new questions, new things only. They are not the routine questions. And JEE paper is always the something like different. They always use basic concept in a different manner. Okay, now you check this question. This question I have prepared from Claden. Theory part. Now you check this question. So don't expect a tough question. You need to solve question. They may have some illusion. They may have some trap in options like that. Or always they will use the basic concepts. I'm telling you again and again. Don't focus much on the exception cases. They never ask exception case. So please always focus on the basic concepts. Haji, answer is AD. Everyone?
Yes, sir.
This question is okay. I'll tell you this question, how to solve this question. Answer is A, D is a perfect answer. Yes, absolutely. Answer is A and D only. This question, actually, this theory is given in Claden. The theory is very much simple, very much simple. Whenever there is a cation stability case, we always simply check that next cation should be better than the previous one. That is the very simple thing. Suppose in this cation, if I want to do migration, the next cation should be better than the previous one. Okay, whether I migrate methyl or I migrate phenyl, in both the situation, the new cation will be better than the previous one. So now you don't think that the next cation is less stable. Next will going to become good stable. When you are getting better cation than the previous one, then simply check which will migrate more faster. Now you should now what is the confusion you may get? Ki, sir, if I migrate phenyl, then I will get this condition. If, sir, I migrate methyl, I will get this condition. What I'm saying, in both the condition, you are getting a better cation than this situation. Our motive is, as compared to this, the next should be better. Both are better. Now don't check out of two which is better. That is the wrong thing. Out of two which is better, don't check. Out of two, you simply check which can migrate fast. So phenyl will migrate fast. So that should be the best answer. Suppose if the next case, what is the next case? Suppose if I am having, suppose this is COO ethyl. Here, suppose I am having some phenyl, here C and this. Now in this case, whether I migrate phenyl or I migrate methyl, my next cation is going to become less stable because this is C double bond O. If you are getting cation here, cation adjacent, if we are having cationic character, there is a repulsion, the condition is unstable. So next should not be less stable. So in such case, instead of migration aptitude, you have to remove that culprit group which is going to create instability. There we should not check migratory aptitude. So now in this case, if you protonate here, pi bond shift like this, here we are getting cation. Next will be better than the previous one. So simply check migration aptitude. If you do protonation here, pi shift here, we are getting cation. Don't migrate phenyl, because if cation become here and adjacent to ester, that become unstable. So now culprit unit, which is going to create instability, that we need to migrate instead of any migratory aptitude. So in such case, phenyl will remain on the para position. In such case, phenyl will come on the meta position. So in P compound, phenyl is on the 3rd position. In Q compound, phenyl will be on the 4th position. Not getting the situation. Bacho?
Clear, sir.
Yes, very good. Now you see this question. The question seems to be like very much easy, but you have to focus very carefully. That type of question they will give in match the column list. That same type of, they will create 4 questions in match the column, 4 this side and 4 structure that side. Like that. They already have asked such type of question. Okay, in such case, what you need to do, simply open this compound here. C2H5, CH, C2H5, that is the front carbon. Back carbon CH, we are having 2-methyl. Now, please simplify the question. 1, 2, 3, 4, 5. So this is the longest chain. So 1, 2, 3, 4, 5. This is 1, 2, 3, 4, 5. 3 number is having like carbon and which is having 2-methyl. Like this. This is the basic actually question. Now you simply check 5-member chain actually. 1, 2, 3, 4, 5, 6. This is wrong. 1, 2, 3, 4, 5. Okay. 1, 2, 3, 4, 5, 6. This is again wrong. Only these 2 compound we have 5 carbon chain. 1, 2, 3, 4, 5. 3 number is having isopropyl. 1, 2, 3, 4, 5. Don't confuse by seeing this hydrogen. We can show hydrogen here. Na? So A and D is the absolute answer. Very good. So that much basic concepts knowledge you should have. And now you solve this question. This is again, don't like get fear by seeing the size of question. If you start question carefully reading, you can easily get answer. A and B.
Yes, sir.
Yes, absolutely fine. Answer is A and B. The same type of question I have asked in first lecture also. So any discussion is required in this question? Any discussion? Bacho?
After in that last line, there should also be hydrolysis added.
Okay, I'll read this question again. Here in this compound with dimethyl sulfate in presence of NaOH gives K. Okay, I'll write this compound. NaOH dimethyl sulfate Me2SO4, that you know the structure of Me2SO4. This is Me2SO4. If someone attack here, the leaving group will remove out. Okay, right. So out of this, so NaOH gives K along with L and M. Okay, right. L and M. In this reaction, product ratio can be controlled by the reaction condition with excess of NaOH. If you take excess of NaOH, both acidic H will move out. When both the acidic H will move out, this is O minus, this is O minus. Here we have CHO with the dimethyl sulfate. Now, out of these 2 anions, this anion more involved in resonance because of the minus M effect of this. So here we will attack to Me2SO4, will get methyl here. Next is 1 equivalent NaOH. Then only best acidic H will move out. That is the para position. Right. In this case, that remains as it is. Now, if you attack on Me2SO4, you will get this compound with 1 equivalent. So this compound should be K, and with excess, this should be L. The same reaction when carried out with excess of NaOH, and only one equivalent dimethyl sulfate, M was formed. Excess means these two will create. Only one equivalent means yani ki this anion should attack. So this should be M. Or if you have Me2SO4 also in excess, then both Me will generate. So the compound L is having both OMe, right? K compound, this is OMe, M compound, this is OMe. Are you getting? Now, why hydrolysis is required? I'm not getting.
I mean, it will be other, O will be ONA instead of OH.
Oh, okay. Acidic workup is understood because as per the option, don't go that much deeper side, because as per the option, it is understood they have done already acidic workup. Right? So don't be confused in that, because there is a no option with O negative Na. So why you are going in that particular direction? Right? Now everyone got this question? And these are the perfect question for JEE Advanced. I'm telling you, these all questions are perfect for JEE Advanced. They never ask a routine question. Yeah, only that kind of question they may ask. And next time I'll give you more appropriate question. These are also absolutely fine. More appropriate question I'll give you. Okay, we'll check this. 1, 2, 3, 4, 4 compound. Anilium salt of compound first means anilium salt. First compound are largely hydrolyzed in aqueous solution. Yes, absolutely. Because of this anilium condition. Array, hydrogen already involved in H bonding. Now, when H bonding, so NH2 and nitro should be in the same plane. So lone pair more closely go into the resonance condition. Nitro minus M is also working because of H bonding, NH2 nitro in the same plane. No SIR working. No steric hindrance is working because now H bonding is there. So both will be in the plane. Lone pair will go in the resonance because of nitro minus M effect. Now the basic strength reduced. Even if you go for anilium salt, it will immediately withdraw the H electrons and move towards the resonance. In that case, it H plus will easily release in aqueous solution. First statement is correct. Compound second is insoluble. Yes, yeah, absolutely. In aqueous H plus condition, lone pair is not available. A 2,2H bonding more in the plane, and 3,3 minus M will pull the lone pair inside. Lone pair not at all available. So it will be insoluble with aqueous H plus condition. Lone pair donation possibility is not there. Also correct. Compound second readily undergoes hydrolysis. Array simple SNAR reaction. 3 withdrawing group create electrophil. You know the SNAR na. In SNAR, withdrawing and leaving group should be on the ortho position. So here 3 withdrawing and NH2 leaving is on the ortho para position. So they will create electrophilicity here. Water can easily attack. Right? If you know the SNAR condition, na beta. Right, here nitro, here nitro, here nitro. These condition like water, if it is attacking here, pi bond will shift here. You will create some carbanion character, not character, exactly carbanion intermediate. Here we have NH2 and here we have H2O plus. It will come back and remove this NH2. Even bad leaving group we can remove in SNR condition. So that can easily undergo hydrolysis because 3 nitro group create that much electrophilicity that even weak nucleophile can attack. So this statement is also correct. If you know about SNR, compound 4 is more basic than compound first. Absolutely correct. Yeah. So all options are correct. A, B, C, D, all. This is given in Peter Sykes, theory part only. Right, everyone? Any doubt? Anyone is getting any doubt? Okay. Last question for you. That kind of question already came in JEE Advanced. But this is not the same question. The type of question already came. Dash N3 means I should be on wedge. Wedge I, it means BR should be on dash. BR dash. then OH should be on veg. So in the initial compound, methyl to by default veg, OH should be on the veg. So veg OH replaced by dash Br. Dash Br replaced by veg I. Veg I replaced by dash N3. That answer will come. So Me and OH both should be veg. This is correct. This is wrong. This is wrong because if you flip the compound, methyl position will change. So that is wrong compound. This compound is correct. If you flip the compound like this, methyl will come this side and both will become veg. This is wrong. This is, you simply rotate this compound. The methyl will come that way. This is again correct. This compound you simply flip like this. This is also correct. No, this is wrong. This is wrong. Now how many answer? 1, 2, 3, 4. Okay. Yes, absolutely correct. Answer is 4. Right? So, what do you feel? These questions are, I know these all questions are perfect for JEE Advanced. Next time, I'll increase the number of questions, right? Thank you, everyone.
Thank you, sir.
Thank you, sir.
Yes, sir.
So, so could you explain, in the previous question I have a doubt.
What doubt?
So, the basicity, how do you compare the basicity between 4 and 1?
Abba. Hey, what you are asking? Come on. Karan. Hey, simply nitro minus M effect will withdraw the lone pair towards the ring. Lone pair availability is less. Here lone pair availability is better than that. So first should be better base than the fourth should be better base than the first.
So, but NO2 is bulky, right? So won't it like push it out a bit?
So because of H bonding, there is no meaning of steric crowding. Come on. Because of H bonding, it will be in the plane, not out of the plane. Bulky doesn't make any sense, yeah. Here we have hydrogen bonding. Because of that, both will be in the plane. Because they are in the plane, so minus M effect work more effectively. Now it will pull the electron more effectively. Hydrolysis meaning in which part? This part, right?
Option A.
Option A. Hydrolysis meaning is what? Simply releasing H plus or OH minus ion. So suppose if in this case anilium salt you are having, so this nitrogen already lost its 3 resonance structures because now lone pair is not participating anymore. So to get those more resonance structure also, it actually withdraw the electrons of H, release the H plus, and it will now in the resonance will get more resonance structure, more stability, and releasing H plus or OH minus, and that is called simply as hydrolysis.
So in option C, we were removing an NH2 minus, and that's also hydrolysis.
Removal NH2. Yes, because if I'm using water somewhere actually and breaking the system, that can also be the part of hydrolysis. Yes,
Okay.
that is also correct.
Okay, sir.
Okay. Any more discussion? And bacho, suppose if you have any small confusion in any concept, you can just ask those concepts in next session before starting the session. Like before starting the quiz, you can ask those basic concepts, suppose small concept if you have any doubt, right? So that we can close those small things. Yes, Karan?
So could you cover basicity and acidity strength, like these questions?
Basic strength, acidic strength, topic discussion.
Yeah, like these concepts of hydrogen bonding examples and other things.
So you have not read these small things like H bonding and all. Okay, no worries. I'll discuss. Don't worry. In the next turn, we'll discuss basic strength, if you say, or acidic strength, whatever you say.
Yes, sir.
Right. I'll discuss in the next session. Don't worry.
Thank you, sir.
Okay.
Sir,
So in the last, whoever like want to discuss those basic and acidic, they will like stay here in the class. Remaining student, they can leave in the next session when we'll discuss this acidic or basic, right?
Sir,
Yes.
I have a doubt in a compound. In case of NN2 trimethyl aniline, will there be SIR?
in NN
2 trimethyl aniline.
NN, acha, okay. NN2 trimethyl. Yeah, there is a steric hindrance. There will be steric hindrance. What is wrong in that? Yes, there will be a steric hindrance. It may move out.
Yes, sir.
ठीक है बच्चों, next turn we'll discuss acidic or basic strain. So, right? Okay. Thank you, everyone. Thank you.